Hello everyone, I am Ripun Kumar Saha from Arizona State University. I am excited to present our work on Turb-Seg-Res, a segment and restore pipeline for dynamic video with atmospheric turbulence. This research is a collaboration with Dihao Quinn, Niani Lee from Clemson University, Jinwei Ye from George Mason University, and my supervisor Suranja Ashurya from Arizona State University. Let's talk about current challenges of video restoration in turbulence. When shooting a foreground with static background in a kilometers of distance by a camera which is shaking, it is adding some motion on the video. Also, the foreground motion adds second set of video motion. Because we are shooting in long range in turbulence, each pixel is dancing randomly. It adds third set of motion. So jointly, it became very hard to restore the video in turbulence. This is an example video of how turbulence effect looks like with object in motion. This is our video enhancement pipeline in turbulence. We developed a segment then restore pipeline for video in atmospheric turbulence. Once we get the original video, the first step of the pipeline is fast stabilization. Let's talk about that. Most of the high focal length camera are vibration sensitive and they require stabilization. However, traditional method that based on shift, sharp and warp fails because turbulence introduce a lot of error inside the video and those descriptor kind of fails. So we use GPU accelerated cross correlation to estimate motion and stabilize based on that. We can see the stabilization is really useful here because if you take the temporal mean on the raw video, the images are really blurry. However, taking the temporal mean on the stabilized video is pretty sharp. Our method is particularly useful in extreme motion in long-range video, where Premiere Pro warp stabilizer fails to stabilize the video. Now let's talk about average optical flow based foreground and background segmentation. We perform motion segmentation based on average optical flow computed by pretrained raft from current frame to the in nearby frame. The number of frames is selected optimally to ensure best segmentation of moving object versus static background. This method is quite robust in long-range video with atmospheric turbulence. Let's see some of our results. Now let's talk about the adaptive filtering on the static background. We found that CN square or turbulence strength follow the ratio of temporal variance and spatial video gradient. Once we calculate this pseudo CN square, we select 3D Gaussian kernel of similar ratio and apply spacetime adaptive Gaussian blur based on the turbulence strength present in the video. In essence, low turbulence video is already sharp, the CN square is low here, so it will select very few frames, close to 1. However, high turbulence strength result huge distortion and it results in higher CN square. Therefore, it will select more frame to average. We found that most deep learning method introduce a lot of artifact and distortion with temporal inconsistency. However, our adaptive filtering approach on the background appears very clean and smoother. After adaptive filtering approach, we combine the background and foreground. Then we train a restoration transformer with our proposed simulator to remove the residual blur present in the video. We use procedural noise generation technique for realistic looking turbulence video generation. We generate 3 sets of 3D noise for space-time pixel shift as well as space-time blur. Based on the pixel value of first set of 3D noise, we shift each pixel on X direction, corresponding to tilt on X direction. Similarly, another set is used for tilt on Y direction. Third set of 3D noise is used to assign space-time blur amount at each pixel of the video. Visual quality wise, our simulator can produce similar quality turbulence video comparable to P2S but with fewer pixel artifacts. Unlike others, our simulator can generate video without any pre-computation or without looking at a fixed set of pre-computed metrics. Besides, our simulator can produce any arbitrary size video. To the best of our knowledge, this is the first open source turbulence video simulator that can produce turbulence video with temporal consistency. Also, this simulator is extremely easy to use and can be integrated to other models for dataset generation. So check it out. Let's see our video enhancement pipeline in action. Left input video show heavy distortion because of the turbulence. The right side show that our enhancement method is really good at removing the video distortion caused by turbulence and make it much stable, smoother and clean. Our method also works really well on OT's dataset and make it much cleaner than other approach. Thank you for your time. Check out our website for code demo and dataset information.